we'll see if the right answers are actually on this list. It says calculate the energy in joules per photon of the light that is emitted or absorbed in the following electronic transition in the helium ion. So this is going to be helium. So its nucleus is going to be 2 plus or plus 2. And again, so as you go away from the nucleus, you'll go to n equals 1, n equals 2, n equals 3, etc., etc., etc. And this one is for n equals 2 going to n equals 1. And that is an electronic transition, so the electron is moving. And while we do these calculations, again, I want to emphasize that one important thing is that when an atom absorbs energy, an electron moves. So now an electron, as the electron moves closer to the nucleus, the atom will emit energy. In the form of a wavelength of light. As the electron moves closer to the nucleus. And in line with something that we said in a previous homework question, so the position of the electron closer to the nucleus is lower energy. So higher energy going to lower energy, so the atom must emit energy. Anyway, any questions about that? Because this is what we're calculating, is the energy of what's called an electronic transition, which is an electron movement. Okay. Well, so the equation is one that we've seen before. E equals minus 2.18 times 10 to the minus 18 joules, z squared, 1 over n final, I made the bit f big, but it should be a subscript, squared minus 1 over ni squared, like so. Then plugging in numbers, so this time, so z is 2 for helium, because 2 is the number of protons in a helium atom. And now I'm just going to go ahead and fill everything in. So minus 2.18 times 10 to the minus 18 joules, 2 squared, 1 over n2, squared minus 1 over, oh, sorry. My final state is n equals 1. So let me scribble that out. 1 over 1 squared minus 1 over 2 squared, like so. All right, it's always final minus initial. Okay, and then multiplying this out, let's see if we get something that's actually on this list. 2.18 minus exponent 18 minus, sorry, I have to do the part in parentheses first and then work my way across. So 1 over 1 squared minus 2, hold on, 1, wait a minute, I think I might have done something that order. 1 squared, 1 squared, 1 over 1 minus 2 squared. Oh, I think that's the problem. There's an order of operations thing here on my calculator that doesn't normally do for other calculators that I've used. So this should be 1 minus a quarter, so it's 0.75. I might have to go back to doing it by hand here. Now if it's 0.75 times 4 times 2.18 minus exponent 18 minus, I get 6.54, oh, something's up here, 0.75 times 4 times 2.18 exponent 18 minus 6.54 times 10 to the minus 18. And it should be negative. So also not an option. I will have to work on this problem too. And again, this is joules. It's also joules per photon, and it is not kilojoules per mole. Sorry about that. Any questions about this one? As far as the work shown anyway.
Yeah, I have the same thing going on with mine. I followed along and I got -4 something 19 for mine, and I was going from N4 to N3. So I don't have that as an option for any answers either.
Okay, thank you, Selden. And again, I apologize. I will take care of it. And I will take care of it by tonight so that you will be able to solve these problems as of tomorrow. And one of two things will happen. If I can't fix it, I will figure something else out. But okay.
If it helps you out, it looks like you put 2 of the same answers on each one of them.
I did. Oh, yes. Well, thank you. Further issues, huh? Let's see. So E equals -2.1